said try to make your session interactive, and I thought, well, how do we do that? So here we are. And the way that we're going to do that, come on in. We're just getting started with a little fun game to start. The way that we're going to do that is here's our controller, and it's a little fragile, but our controller's right here. One of the 4 people will be sort of the up arrow, one will be the down arrow, one will be the left, and one will be the right. And then later we'll get a 5th person who will actually be our player. So, 4 volunteers. I saw some hands over there. 1, 2, 3, and 4. Here, come on up. So this little device here is called a Makey, and what it does is it allows you to interact with the real world and have. We're going to get these guys to kind of control things. So I don't know. One of you come over here. We'll try to keep it quiet. I'm going to get you guys to hold on. If I can get you to hold on to that toonie there.
The toonie
yeah.
So I'll go down.
Yeah. So you'll be down. Next one can be up. And here we go with the, is that right? All right, so these 4 people are directions. So they're going to be standing here, and the 5th person, whoever the player is, has to touch. There's the skin-to-skin contact that we were talking about. Has to touch. If I want to move to the right, then I'm going to have to touch the person to the right. So it's a little bit of teamwork. So I need one more person to kind of be our game player. Come on up.
You gotta do this
now, I don't know how this is. Yeah, there we go. So I'm going to let you guys kind of sort out some kind of sorting mechanism here and make this work.
So if you're up, down, left, right.
Up for you. I'm up.
Down.
So it's opposite.
You want to
yeah.
All right.
So then I can be up, down, left, right? Yep.
And obviously you have to watch the screen while this is live. And you just tell me when you're ready to start things up here.
Hold that down.
I'm ready.
Oh, man. Good job.
Oh, yeah. Yeah.
Thank you very much. That was way better than my previous the little game that we played here at the beginning wasn't really a coding type of game. More sort of interaction. And later on, I'll show you kind of what you can do and actually use coding with these sorts of things to make interaction with the computer much more personal. I guess we'll get started. My name is Dave Renova. I'm a math teacher, high school math teacher, and I do this kind of thing for fun. So this is what I like to do for fun. So we're going to talk today a little bit about coding. A lot of people see some really good math connections with coding. We're going to look at some connections that maybe go beyond math and try to make this as relevant as possible for as many different people as possible. You can find the presentation here. It will be on every slide, so you can sort of pick that up at any time. You don't have to get it down right now. Come on in, guys. If you. Okay, yeah. Try and find a good spot. The session said that this was geared towards from middle school to high school. I've done activities like this with students as young as sort of grade 2, so it does work. It totally depends on the students. I think in order to do this, students have to be able to do a little bit of problem solving and a little bit independent. I don't have a lot of experience working with kids that are that young other than my own kids, so I'm not sure how it works at that level, but I have seen it used very successfully, sort of grade 2, 3 on up. And there are some tools we'll talk about a little bit later that you can use for even kindergarten to grade 2. Tools a little bit different, but the ideas are still the same. I guess the first thing we should talk about is what is coding. That's one of the things that I'm often asked. What is coding? Oftentimes it looks like this, or a lot of people think it looks like this, and if you're a professional coder, it probably does look like this, but it certainly doesn't have to look like this. The idea behind coding is that we can find a way to give instructions to a computer to execute whatever it is that we want it to do. And the way I tell students this is that a computer, we often think computers are, wow, they're really powerful, they're really intelligent, but somebody tells the computer what to do. And that's kind of where coding comes in, is that if we can teach students how to give instructions to a computer, then that's really where the power is. The nice thing about coding is that it embeds problem solving. It's by nature problem solving. Professional coders use coding to solve some sort of problem. Maybe it's a great book for an iPad, for instance. It's a problem. There's nothing good to sort of keep track of grades and observations and computations, that kind of thing. Somebody might see that as a problem and say, hey, I'm gonna solve that problem. I'm gonna develop an app that will do all of that. So lots of problem solving, and that can happen in sort of big context, but also right down to little bits where we can have students in classes solving problems, coming up with unique solutions, not just sort of cookie cutter type solutions. Coding allows students and others to be creative. If I give you a problem and say, hey, I want you to create an app that does whatever, and that's all I tell you, we're probably going to have a whole wide range of different sort of examples that come up as a result. So it allows our students to sort of share their creativity with us, and sometimes, I teach math. We don't see a lot of creativity in math, so this is one way that students can be a little bit creative in math. The nice thing about coding is that you know right away when you hit the button to make the thing run, you know if it works or not. You don't have to call me over to say, hey, did I get this right? If you are designing an app that calculates 1 plus 2 and you get an answer of 5, you know that you've gone wrong somewhere. So that feedback happens right away because students see that it works the way that it's supposed to, or that it doesn't work the way that it's supposed to. So an example that we did with the game, if the left arrow makes the Pac-Man go to the right, it's obvious that there's a problem there. So that immediate feedback is great for the students to be able to make adjustments to their learning and go from there. Coding can be very engaging. It's kind of like solving a puzzle. Lots of people sort of by nature like solving some kind of puzzle, and that's really what this is all about. It's how do I get this computer to do what I want it to do? And for a lot of students, that's a really powerful thing. And again, they can be creative in their solution as well. We might talk about why do we want students to code. I think one of the things that we see is we see lots of technology. We use it every day, but how often do we get a chance to actually create with that technology? So rather than just being consumers of technology, if we can teach students to be creators of technology, and we can see some really powerful things. It's empowering. You give a student a computer, and they, at the end of the day, come up with this program that does something that allows the computer to do something that wasn't possible before. And the student says, wow, I did that. And some students will kind of take this far beyond what you can imagine. So I often hear stories of teachers who do a little bit of coding, and then their students are going home that night, and they come back the next day with these crazy sort of additions to their programs, their apps, and that sort of thing. So really empowering for students to be able to say, wow, look what I created. Somebody actually is interested in the work that I've created. The other reason for coding is it provides opportunity. There are lots of stories of 12 and 13-year-old kids who've created apps for iPhones that are on the market that you can go and download right now. That's a pretty nice opportunity for somebody that's 12 or 13 years old to say, wow, I have an app in the App Store that you can go and download. The other opportunities that are available are job opportunities. And I'm not saying that that's the only reason why we should teach something, but it's predicted that by the year 2020, which sort of seems like it's far away, but if you think about it, our grade 9 students are going to graduate in 2020. By the year 2020, in Canada alone, there's going to be 180,000 jobs that can't be filled because our students don't have the skills that they need. So these are tech jobs right here in Canada. In the States, it's predicted to be, I think it's 1 million jobs in the States that are going to go unfilled because the students don't have the technology. So there's an opportunity there for our students to get in on the ground floor, so to speak, learn some of the skills. They might not use these skills every day in whatever job that they choose, but at least it gives them an understanding of some of these jobs that are going to be out there. And why code? Well, it's a challenge. As I said earlier, it's kind of like a puzzle. And when students overcome that challenge and they're successful, the pride that they feel is pretty amazing. It seems difficult at first, and I guess we talked a little bit about productive struggle. They kind of struggle through it, and when they get through it, there's like some huge sense of accomplishment. I've done some work in some grade 7 and 8 classes where students are struggling, and then by the end of it, they kind of nailed it, and they're high-fiving each other saying, yeah, we got it, because they worked together to solve some problems that at first seem impossible. I can't do this, it's really hard, and then they're able to work through it and be successful. So I think there are probably lots of other reasons. These are 4 that I think are big ones. How can it be used? That's another thing that we should talk about. If you're here learning about code, that's great, but we don't have, in Ontario, we don't have a coding curriculum, so how do we work this into the curriculum that we currently have? We heard Jeff today talk about storytelling. This is an opportunity for students to tell their stories. You can create sort of animated stories where it's, instead of using a video camera and some editing software, you can actually create an app that tells that story. So it could be an animated story where the students are creating the script and the graphics that go with that. In addition to just being a story, a static kind of story, we can incorporate some interactivity. And obviously, most of the apps that we would use on a regular basis have some kind of interactivity. The Pac-Man game, you have to use the arrow keys to move the Pac-Man around, and that sort of thing. So, and there are lots of ways that we can do that. Problem solving is a huge one. I sort of mentioned it earlier. It's a way that we can get students to do some problem solving, and we can actually see their problem solving because of the problems that they are solving to get their computer to do whatever it is that they're doing. And I really like the idea of physical computing. Physical computing is one of those things that for those students that are very active in class, find it hard to sit down and stay focused. Once you can make it sort of physical and they can see that something that they're doing on the screen can actually make something happen, whether it's sort of a little ball that they sort of program to move around the halls, a little Lego kind of robot that they can, again, program to interact with things. This one was designed to move towards this block and move it around. For a lot of students, that is where the learning really comes to life, because it's not just something that's happening on the screen. They're not just moving bits around, they're actually making something physical happen. And then you can kind of move up from there. Where do you start? It's such a huge topic. I'm going to give you a few options today. The Hour Code was started, I guess, I want to say probably 4 or 5 years ago now. Some tech company CEOs decided we need to make sure that students know how to code so that we have people that we can hire, so we can have a workforce. So they put together what they call Computer Science Education Week. And during that week, they try to get as many students across the world to participate in 1 hour of coding. And the idea there is that if we can get students to do 1 hour, and we can get their teachers to be interested in, maybe it will extend from there. So the Hour of Code is a great place to start. They have very simple sort of 1 hour type activities, and it really focuses on very basic stuff. So you don't need to know anything about coding. You can go to the website, and when you go there, I think last year they did a Star Wars one and a Minecraft one, so stuff that kids tend to really enjoy, where they had to tell, you know, the Minecraft person kind of where to go to avoid the bad guys kind of thing. And it's all done on the web, so you can do it on any kind of device at all, and no sign-in required. It's meant to be really easy and really accessible. So if you're looking for a place to start, that's a great place. Scratch is a program that was designed at MIT specifically to get young people, and I think they're the ones that kind of say grade 3 and 4 and up, young people to get into coding a little bit. The tools are very easy for young people to use, but also very powerful. So you can actually do a lot with them. So it's not like it has it's very limiting. It's very easy to get in, and you can keep going. We'll see some examples in a minute. Yeah.
Are these mostly online, or do you have to download them?
These Scratch is online. You can do a download. They used to make it only downloadable, but now it's available online. And these are all links, so if you click on each of these images, it'll take you to the site there where you can see those things. Scratch Junior, so Scratch, the disadvantage of Scratch is that it's flash-based, which means it doesn't work on an iPad. Really, really powerful tool, doesn't work on an iPad. I know there are lots of iPads in schools, so we'll talk a little bit about some other options here. Scratch Junior is kind of like the iPad version, but it's really geared towards students K to 2 or 3. Yeah.
In our board site, we have Scratch. It's on the general news. We do have Scratch.
Perfect. Excellent. And then Scratch Junior is an app that you can download. It's just meant for iPad, and it's kind of like a stripped away version of Scratch, really meant for students to work on storytelling and moving things across the screen. And I've heard nothing but good things about it. If you're looking for iPad options, there's this one here called Hopscotch, very similar to Scratch, but it does work on an iPad, and it works. Somebody else decided, hey, Scratch is fantastic, but I want to be able to use an iPad, so they created this other tool called Snap. It looks identical to Scratch, and if you were to follow along with what we're going to do today, everything would work exactly the same way. I think the only difference is that the library of images that are available may not be quite as big. And then Tickle's another one that you can use on an iPad. So it will do a whole bunch of things. You can code their little logo as a whale, so you can code this whale or some other character to move around the screen. But it also allows you to control things like these Sphero balls and things like drones and that sort of thing. So you can actually have kids writing programs for drones that would, fly across the room and do different things in the room. So there are literally hundreds of these tools that are available. These are probably some of the most popular ones, and I'm going to focus today on Scratch just because it is so accessible and easy to use. Here are a couple of different examples of what you might do. My daughter was in grade 1 last year. She came home. She was super excited. She learned about the sun, and she couldn't stop talking about it. She'd tell me all these facts about the sun. And I'm like, how do I take that energy that she has for this sort of project that she did in the sun and kind of bottle that and continue that learning at home? So I said to her, why don't we sit down and you can write a little program and you can tell me all about the sun and put it into your little program. So it sort of looks like this. It's nothing fancy, but she was 6 at the time. But it'll give you some idea of what you can do. So it's a simple program. The sun is there. You can see the Earth, and the sun kind of spews out some facts about itself. And then, so I said to her, well, that's great, but how do we make this animated? She said, well, what if the sun gets big because it's really, really big? I said, oh, that's a great idea. And then she said, well, the Earth is supposed to move around the sun. And I said, okay, well, why don't we have the Earth move a little bit and share some information about how long that takes. So for her, this was a really great experience. It didn't, this is probably, I don't know, half an hour of work on her part to kind of go through this process. And she was so excited to be able to actually take the learning that she had, had from school and to be able to apply it somewhere and do something interesting. Obviously, we can do a whole bunch of other things with that. again, I'm a math teacher, so to me art looks like very much like straight lines and that kind of thing, but you could always make this a little more interesting. This is done just by drawing sort of 8 little squares here and then rotating and drawing another 8 squares. And this one again, just by drawing a bunch of squares, you can see that we can make some pretty interesting things. So obviously a lot of geometry and also some sort of cool looking art stuff. I talked earlier about some interaction. These two examples basically, I think it's in grade 4. Students learn kind of a little bit about Canada and where the different provinces are, and color maps. So somebody suggests, hey, instead of having a student color map, why don't we have them photo map? And so basically the idea here is you move your mouse over top of the different provinces and territories, and it tells you what those provinces and territories are. So very simple example, but something very easy to do for students in grade 4. And this is like the math equivalent of that. So find, tell me what fraction of this big rectangle each one of these colored pieces A, B, C, D, E, and F are. So with a little bit of interaction, obviously we can sort of build in some more interaction as well. I mentioned already, I'm a big fan of the physical computing because I think students really like the idea of seeing something happen. You start as simple as something as the spheros. The Legos really complicated. I've seen people make printers out of these little Lego robots where they basically stick a pen in the robot and the robot has this message of, okay, I need to move this way, and then by the time it's done, you have this sort of hand-drawn, it's not hand-drawn, computer-drawn image of that was programmed into it. And then the Makey, again, not really a tool that students use for coding necessarily, but it's a tool that allows them to make their programs interactive outside of the computer itself. And the classic sort of Makey example is this banana piano. So you can make an app where you can actually just visit a website that has a piano on it. You hook up these bananas, and as you tap the bananas, it plays notes for you. So again, for those kids that are really kinesthetic, it gets them moving and doing some stuff as well. Again, my son came home. He's in grade 4. He's in French for the first time this year. Came home really excited because he knows his colors in French, and he's telling me all his colors. Dad, ask me ask me a bunch of colors. So again, I said, hey, why don't we make an app? And that's what this picture here was. His app was, he had on the screen, it would he recorded his voice saying all of these different colors, and so the computer would randomly choose a color, and his voice would be saying, rouge, and he would have to touch on the red little ball over here to say that he's actually figured out what red is, and then it would cheer if he got it right, and kind of play some bad sounds if it wasn't right, and go from there. So from him, he was just supposed to be able to recognize, but he did so much of that. He did all the typing, so he can actually spell all of those words as well. So just taking what he did and working beyond that. We're actually going to do some coding, and that's really what I want. I want to give you a chance to kind of play and mess around. If you have a computer, you can go to the website here, scratch.mit.edu. If you're following along, you just click on the link there. If you're on an iPad, is there anybody that doesn't have a computer? I have 3 here if you want one. Okay. If you are on an iPad and you really like it, as I said, you can do this on Snap. Everything looks very similar, but some of the extras may not be there. I'll just give everybody a chance to kind of get there. And just as we're waiting for everybody to get there, what we're going to start with, I'll bring it up in a second, but what we're going to start with a really, really simple program that just makes a square. So that's kind of our goal. We'll start somewhere. We'll start with a program that makes a square. So in order to do that, we have to think about what kind of instructions do I need up here if I'm going to make a square. So if you're going to tell me to walk in a square, what kind of instructions do I need? And this kind of gets to the point for students that we have to be very specific. Don't say just walk in a square because I don't know what a square is. So what do we need to do in order to walk in a square? Yeah.
Walk forward.
Yeah, walk forward. And then I often do this with students, and they just keep walking. Like I say, listen to your part. Like I put them in groups, say, listen to your part, or walk forward. I'm just going to keep going right until I hit that wall, and just stop there. And then the kids say, oh yeah, okay, I need to tell them how far to walk forward. So we'll pretend that I know what you mean by walk forward. So I walk forward.
Walk forward 3 steps.
Perfect. And then what do I need to do?
Stop.
Yeah, so turn left, I heard, or turn right, it doesn't really matter. And Paul was very good, very specific about how far to turn, because if I'm just going to turn left, I might turn like this, and suddenly I'm headed off in this direction. If it's going to be a square, I need to make sure that I'm turning 90 degrees, so I turn 90 degrees. And then what else? Yeah, and then I can walk my 3 steps, and we can kind of just repeat that process. So we're gonna go through this right now. When you get to the Scratch website, it looks sort of like this, maybe not.
So are we going to try it out?
Yeah, we're going to try. I just want to tell you a little bit about the page here. You don't need an account to use this, but if you have an account, all of your files, all the work that you do gets saved. It's free. There's no cost. It's run by this group at MIT. Privacy, I don't think is an issue here. Anyway, we can use it without creating an account. There's nothing wrong with that. Down here, you can see a whole bunch of examples. We won't look at any, but if you're looking for what kind of things can you do with Scratch, these feature projects are often a great place to have a look and see what's available. Yeah, we're gonna go to try it out here, and we're gonna get started. When you first start, the screen will look something like this. This space over here is kind of what we call the stage. This is where all the action is going to happen. When you run your program, that's where it will be. All of the tools and commands are in the center, and over here on the right is where we're going to write the code that we need. This is a little tutorial. I'm going to kind of walk you through some of this. I'm just going to close that to make up a little more space. The first thing that comes up is this cat. This is like a Scratch mascot. We can change that. We'll maybe get into that a little bit later if we have time. But for now, we're going to get our cat to make a square. So let's do it. The first thing that we need to do is when we tell this program to run, or the way that we tell this program to run is by clicking on this little green flag up here. So when we have a little bit of code, we're going to click. That's kind of like our go button, and we're going to get started. So in order for our program to do what we want it to do when we click on the play button, we're going to slide over here to the orange toolbox called Events. And we're going to grab one of these blocks. So each one of these is called a block. If you look closely, you can see they almost look like little Lego pieces or puzzle pieces. There's a little sort of bump here on the bottom, and we can have other pieces attached to that, and they just kind of snap right into place. They'll have a little indentation, I guess. So that's our first thing. When the green flag gets clicked, we want to move a certain number of steps. So under motion, and I'm just going to drag out one of these move 10 steps. And you can see that as I get close to it, underneath the orange is a little white bar indicating that if I let go, it's just going to snap together there. So this will tell our cat to move 10 steps. You can try it out if you want. You can click on the little green flag and see that your cat does in fact move 10 steps. Everybody okay so far? All right, so the next step was to turn 90. So right underneath the move 10 steps was a turn 15 degrees. We're gonna drop that in there.
15 or 9?
Yeah, we want to change it to 90. So the default here is 15. I don't know why they chose 15, but we can just change it by clicking inside the white box and changing that to a 90. And 10 steps is not very much for this cat. In fact, if we run this 10 steps, if you did run it, you probably didn't really see it. So I'm going to change this to 100 steps. And we said we need to do this 4 times. Computers are really, really good about doing stuff over and over and over again. So we could actually just do the same thing 4 times. Or we can use a repeat statement to tell our little program that we're going to repeat this. And we need to do it 4 times.
Sorry, I added a sound.
It's okay.
I wanted to know when the cat turns, so I found sounds and it plays a meow right after he turns 90.
Perfect. And And once kids discover that, they'll play them with that for hours. It's pretty funny.
Oh, yeah.
It's hard to get them back. But, so I'm going to click under the, I guess it's kind of yellow, the one that says control. It looks different on every screen, it seems. Right under the events is a control. And there's this repeat block here. It says repeat 10. Again, we're just going to drag it out. We don't want it to repeat 10 times. You can see it kind of looks like a, I guess I used to say an alligator mouth. Maybe it's more like a hippo mouth. And as I move it, it will sort of eat up all those chunks of code that are already.
That's cool.
And we don't want to do this 10 times. We only want to do it 4, so we can click in the little box here to do it 4 times. And again, you can run this and see what happens.
That was pretty much fast.
That was pretty fast, right? And if you're not watching very carefully, I don't know why, but sometimes you do it, you can't actually see the cat move. It just goes, and I did it a couple nights ago, and I didn't see anything, because normally you see a little bit of a flash. So we're going to slow it down a little bit so we can actually see what happens. And the other thing that we can do is we can actually make the cat draw this image as well. So not just move in that direction, but let's make it leave a trail behind it so we can see where it went. So we're going to drag one of these weight blocks out. It's the first one in the control. And I'm just going to stick it after the turn. You can choose 1 second. You can change that to any number of seconds. You can even go partial seconds. So 1 second is a bit long. 4 seconds to draw a rectangle. I'm going to go 0.5. You can do whatever you like. And then that you might see it move a little bit, but it doesn't actually help you see the square. So I'm going to click on the green pen set of tools. And there's a command in there that says pen down. So right before I get into this repeat statement, I'm going to drag and drop that pen down. Because we want to put the pen down and then kind of walk around in a square and see its path. Then if you run it now, you should see.
I'll take the sound bit. Can I just scoop it out then?
Yeah, you can. That's a good question.
Because this guy is mad at me, so I don't think
If you don't like any of your blocks, you can actually just pull them right out and you drag them back into the toolbox and they'll disappear.
I didn't pull it out because I can't get mine out.
And if you can't get it out, if I wanted to take this move out, I can just move the other stuff and then kind of disconnect. A bit of a two-step process there if there's stuff underneath. I think I need that back, but I'm sorry.
And, oh, so okay.
Everybody have a square? Everybody not?
My behavior is not connecting.
Do you want
I'm
to
not sure why.
Sure.
How do you refresh the page to get the square off?
That's a really good question. Under the green tools is a clear option. So the first one here, if we drag this clear and stick it right at the very top, every time we click on the green flag, it's going to clear the screen.
Yes.
And that way you don't see your previous.
You're cool.
Very good.
What I would like you to try is to try to make a triangle. You know, you've seen a little bit about how this works. We'll make it easy. I mean, we could make this difficult and say that it can't be an equilateral triangle, which makes things a little bit harder, which gets into maybe some trigonometry. But we'll make this easy, and let's make it an equilateral triangle. So all the side lengths are the same, and all of the angles are the same as well. I'll give you a minute to give that a go. You guys are much quieter than other groups. Mostly children. Hear a lot of cats. Yes.
Yeah.
There's a go to command right here and 00. Okay, white is yeah, for sure. Everything was clear.
How do I get rid of all this junk?
Yeah, so
Obviously that's not a triangle, right?
right. So if you want to get rid of it, then just use this over here.
Oh, that's
You
not
just
there.
drag it and see that pop your phone.
Look at that bottom sign.
Let me see your code.
Right there?
If you're done, some people are still working on it. If you're done, you can try a couple others. You can try some of those. Right. Excellent. So you figured it out. So the pad is moving right here. And when it turns, it should start here. Yeah, so what happens is that 60 degrees is internal, and when the pad is turned, it's the angle on the outside of the triangle. So from this pad, then you should go. Is that right?
How many steps
Sure. But it's amazing how quickly they're able to pick up. Because they do what you did, right? They say, oh, this doesn't work. How else can I do this? And they start messing around, and then they talk about, no. It's just because it's the external angle. That's too many times you turn outside the screen. There's a go here right here.
That did not look like a triangle.
Oh, yeah. Most of the colors you click on everything and you go pick a light already. How you do it for color that's not on the screen, but yeah.
Go to exponent 0.
Some of you lost your cat. It took off the screen. We can make it come back. Under the motion, there's a command here that says go to X, Y. I'm not seeing it. Oh, here it is. Right here. About, I don't know, probably a third of the way down the list. The center of the screen is 0, 0. So if you don't even have to attach this to your program, you can actually just stick it out here, change these numbers to 0, and if you click on it, your cat should hopefully come back. Maybe even the same day.
Oh. Didn't work.
Nasty. Yeah, for sure. Right. That will take it to 0, 0. You can rotate it. You can have it going to the direction of 90. So 0 is up, 90 is small.
Yeah.
Yes. If you right click, so if you want to copy that repeat statement, I think if you right click on it, there's an option.
Oh, yeah.
That's great. Oh, yeah, it looks good to me. No, in order to do that, there's a command down here that says point in direction, and we're down here. If you drag that out, you can change this to 90 degrees. 90 degrees is sort of that way. I think you did the right side up at that point. Oh, there it goes.
Dave, how do you insert the words? Like you said, your daughter to put words?
Yeah, we're going to do that in just a minute. So you see some similarities here between the square and the triangle, and if you went on and tried to do a pentagon and so on, it's all fairly similar. So we can actually just modify our program a little bit so that we can actually ask the user, what kind of shape do you want me to draw, or how many sides do you want to have happen in this thing. So we're just going to change our program a little bit so that we can actually not just have one program that does a triangle, one program that does a square. We'll do one program for all of it. So in order to do that, I'm just going to clear in order to do that, we need to ask a question. So the way that we can ask a question, you can do it two ways. If you just want to get text on your screen and have, the cat say something, you can do that under looks. I know it seems weird that under looks you're saying stuff, but you can choose one of these, but none of this is interactive. So you can have your cat say, this is a square. You can leave it up there for a couple seconds, but there's no interaction that's going to happen. So we want to make our program interactive. So to do that, if we slide over to the light blue menu, the sensing one, 5 blocks down is a block that says, ask what's your name and wait. So we're going to, I'm going to stick that right up at the top here, right underneath my pen down. In fact, I'm going to disconnect this because we're going to change things up a little bit. And obviously, we don't want to know what a person's name is. We want to know how many sides, what shape we should draw, so how many sides we should draw. And just to keep things really simple, I'm just going to type in how many sides here. And if we run that, you can see the cat now asks how many sides. A little box comes up asking for input. So we're going to use the input there from the user and decide what shape to draw. Is that okay?
How do you get rid of the, after he says how many sides, is it like a undo function?
Well, as soon as we put an answer in here, this is going to disappear.
Oh, okay.
Yeah, I think. Well, as soon as we tell it to kind of do whatever it's going to do.
How do you rotate one cat?
Oh yeah, good question. Under motion, you can do a couple of things. You can have your cat point in direction. So straight up is 0 degrees to the, what direction is this? I think this is left. It's hard to do this. Yeah, sorry, to the right for you guys is 0, down is 180, and then to the other direction to the left is 270. So if you change this to point in direction 90, I think that will have it go the right way. So what we need to do here is we need to kind of do something with the answer. So as a user of this program, we type in 3 for the number of sides. We need to take that number 3 and somehow do something with it. And in programming, we call that a variable. We want basically a place to store that number that was entered so we don't lose it. So we're going to create a variable here to represent the number of sides and so on. Before we get into that, though, we're going to need, I'm already in this blue menu, we're going to need this answer. So this is the answer that was typed in. Whatever gets typed into this box becomes our answer. If I ask another question after that, whatever gets typed in for that question becomes this thing called answer. So I want to make sure that I do something with this answer so that I have kind of control over it. I'm the one who decides if it gets changed or deleted. So we're going to make almost like a file folder that says number of sides in it. So whenever we want to, we go open that file folder and see, oh, the number of sides is 3, 4, 5, whatever it happens to be. So So under this, I don't know, is that orange or whatever color it is, the one that says data, there's a button here that says make a variable. So we're going to make a variable called number of size.
What's a sprite?
That's a great question. The sprites are these little characters that we have. And we can add sprites. We're going to do it in a little bit. I think we're going to add some sprites kind of down here later. If you went in, I saw some people chose an airplane and some different things. Those are all called sprites. So all these things that we can kind of animate across the screen. And this variable that we have, number of size, really doesn't depend on just this cat. It's kind of what our program is going to do. So we're just going to leave this for all sprites. It means that if somebody else, if we had a dog or something and we wanted it to draw the same thing, the dog is able to access that value, that variable. So once we've created that, there's now underneath, here's the variable called number of size. Underneath that block is a block that says set number of size to. So I'm going to drag that out, and we're going to set it equal to the answer that we received. So we type in 3. That kind of gets stored in this thing called answer, at least temporarily. And then we're going to store it in this variable that we're calling number of size. So it could be 3, it could be 5, it could be 100. Kids like to type in that, a 1 followed by as many zeros as they possibly can. Is that okay so far? No, if I'm going too fast. So then based on the number of size, we have to decide how often are we going to repeat the moving and turning. I'm actually going to start over. And you could use that code over again. So under the control, we're going to repeat, and we're not going to repeat 10 times. We want to repeat a number of times for however many sides. So for a square, we're going to repeat 4 times. For a triangle, we're going to do it 3 times. For a pentagon, we're going to do it 5 times. Whatever number was typed in here is how many times we want to repeat this. So to do that, we're just going to grab that variable, that file folder that's storing our number of sides, and we're going to stick it where the 10 is here. So under data, you can see that the variable number of sides is right here. It's going to drag it right into where it says 10. So now this will repeat however many times we said we wanted size for. Question?
Could you also drag answer?
You could. The only problem with dragging answer in there is that if you ask another question, you might forget that you asked another question and answer is the answer to some other question now. But yeah, answer would work as well. Oh, yeah, thank you. So in order to get it to drop in, you kind of have to take it and not just stick it over here. You need to stick your mouse pointer right over to the white space, right on top of the white space. And you can see that the little box kind of highlights a little bit. Still didn't work? Did you shake your computer? Oh, there it is. Look at that. So far we're going to repeat this some number of times. Remember we wanted to move a certain number of steps, so we'll grab the move, motion. We can do 100 steps again. And then we needed to rotate. It doesn't matter which direction we rotate, but we don't want to rotate 15 degrees. We're going to need some kind of mathematical equation that relates the number of sides to how much we turn. So if you think about the 4-sided figure, we rotated 90 degrees. The 3-sided figure, I think most of you figured out the 3-sided figure. You had to go 120. So this is a good opportunity for kids to kind of play around a little bit, and if we had lots of time, I'd let you figure it out. Maybe some of you know, I don't know, what's the connection between the number of sides and how much we have to rotate? Yeah, sure. We take 360. It's all the way around. We're going all the way around 360 degrees, and we needed to divide it by 4 sides to make a square, 3 sides to make a triangle, and so on. Which I know is a little bit different than the way that we teach geometry, right? Geometry, we talk about the interior angles. So for the triangle, we talk about it should be 60 degrees. But it's a good conversation to have with students about interior angles, exterior angles. Again, I teach grade 9 math, and we're all about the interior and exterior angles. But if you teach grade 4 or 5, then it's a good conversation to have about the angle being outside. And you'd be surprised at how quickly students are able to pick that up. Even just kind of on their own, they say, oh, 60 doesn't work, and they play around, and like 120. And I've had kids tell me, well, 120, that's like 180 minus here. You're doing grade 9 math and you're in grade 4. What's going on? So we need to type this little equation in here. To do that, we're going to type on under the other green, the operators. There's a division sign, and we want to turn, again, we can just drop that in here. I think we heard 360 divided by the number of sides. So we can type the 360 in there, and then we'll go and grab that variable that we call number of sides. The nice thing about the color coding is that if a student falls behind, they can kind of look up here and say, well, where did this green thing come from? Well, it came from under the green menu, and then they can kind of go and find it. Yeah.
First number of sides is 0. There's a number 3.
That's exactly what it is. So this shows us the variable on the screen so that students can actually track what those values are. If students don't like it, it's good for when students make their program. If in the end they decide they don't want it there, they can just click on this little checkbox here. It's still there, they just can't see it. So it's a good tool for them, and it is set to 0 by default. Let's try it out. I'm anticipating we're going to have some problems, but let's try it out. We get some immediate feedback. I don't have a weight in here. It happened pretty quickly, but as the number of sides increases, the cat actually slows down a little bit so you can see it. So. Yeah.
Now, you tend to use the number of sides more than the answer. I was always tending to use the answer. Is that for multi-step equations? That's one of the things you...
So, yeah, that's a great question. So, for instance, let's say we wanted to write a program that calculated the area of a rectangle. I would ask for the length and the width to do that. Now there are 2 answers. Which one is it storing? It's going to keep the last one. So if I multiply them, it's always going to give me the area of a square. It's going to take the answer times the answer, which is the length times the width. Question?
No, sorry.
How did you get the number of sides with the curve on the top of there? It says 0.
Yeah, so if you just click on, it still says 0?
Yeah.
So as soon as you type a number in here, it's going to compare. So now if you type a number, it's going to say, oh, that's going to be your number of sides.
Oh, okay.
Yeah.
How do you get rid of it? Is there a way to get rid of that after you run something? You just put the, is that not like
When you say get rid, do you mean the technical stuff? Yeah, we can, under the green pen stuff, there's a clear. So at the very top, it's probably...
so you have to like code it to clear it.
Yeah, that's right. So at the very top, we can stick it clear so it will get rid of what was there before. Or you can leave it as a fancy pen.
After the clear, I put a grade to X and a Y, so it always puts it on the top left corner, so it doesn't matter the side.
Good idea, because I kind of ran out of space here.
I was doing it when I was in grade 1.
How's the, like, for teaching this to the classes that have done it before, I can see this getting confusing for the, is the help function on this, or the,
Yeah.
it's not, is it fairly kid-friendly?
It's a good question. I'm not, I mean, it's adult friendly for sure.
I just kind of start really slow with the kids, like
Yeah.
square
And you'll be amazed at how well some pick it up, and they're really excited to help others. So that's one of the things that I discovered is that they really like helping others. Oh, you got a whole lot of stuff there. So if you grab this clear, you stick it at the very top. Every time you run your program, you will read clear the screen.
Can you print?
Hold on. The sides change every time it goes down.
It's a good question. I mean, I don't know. Or you can do like a screenshot of just this part.
Nice. That's turn.
So, I'll do this, change this, or take it to 4. Perfect.
you go off the screen, your cat kind of stops at the edge of the screen, and even though you told it to go 150 steps, it will not go 150 steps, so it may not match up. So, yeah. So you can fix that by changing how far. Instead of moving 100 steps, you might make it 50.
Is that why there's a command if on edge bounce?
Yeah, that's more for like if we were going to have something moving across the screen, and then we can make it bounce. It'll hit the screen and kind of turn around.
Just drag it over into the section that has your code.
I put it underneath, go to the next slide here. There we are. So I always go back to that.
What I did is, go to, I put that in right after the yeah, that's, where's the, yeah, where's the, so what does it say? -97. That's what, so I always go to the single page.
No, it's using.
Yeah, I tried swirling.
It's just Swivl. And the course literally. I know. That's a big house. It's really, it's online. It's online. Yeah. And then online, that's like kind of your first where like you drag and drop. Literally writing everything by yourself. That's okay. But there's a course.
Not me.
You guys ready to move on? Yep.
Is there a way then to export this? So like if you create something for, so there's something from my fingers, like this is some for like number of sides, the shapes that they're learning,
Sure.
and then just export this and then just play and go with. Can you do that?
Sure. Let me just show you how you do this. When you're finished your project, and if you're signed in, I'm just going to sign in here quickly. Once you're done, there's an option here to share. So Scratch has made it very easy for us to share projects. All those examples that we saw at the beginning come from people who just make stuff and put it there. So when you share it, it becomes available on the Scratch website, and then you can actually provide a link to that. And all of the examples in the slideshow, you can click on, and you can actually go there, and then you can either just use that code or just play the game. So yeah, that's another way that we haven't really talked about, is that you can actually make games for your students to play and get the concepts that you're hoping. Yeah. Does that answer your question?
Yeah.
All right. We don't have a ton of time, but I think we have time for one more example. I want to do an example where we can work in some user interaction. So I want to go over a very sort of basic version of that Canada map, where we have the map of Canada, and we can kind of move our mouse just to give you a sense of how to do that. And hopefully we'll. Oh, is that really? I'm looking back here and seeing it's.
50 seconds.
That's actually behind.
Oh, okay, I guess we'll stop here. If you want to know a little bit more, there are some. All of the examples are in the slideshow, and you can just have a look at them. There are links to the actual programs. I created the programs, and you can link to them and see what the different bits of code are. There are two more examples. The one is the one is a very simple. Draw a rectangle, and instead of a cat, I just use a little dot here. And when you move the dot over top of the black, it tells you that you're on black. And when you move it over top of the blue, it tells you on blue. So you can actually just click on those links. And then the second one that we won't have time for, it was a little cat and mouse game. So this actually uses the arrows, so you can actually have students make their own Pac-Man game or whatever. So I'll bring it up so you can see it. It's a really simple example of what's possible. And when students learn about coding or want to learn about coding, the first thing they want to do is make games. I started a couple weeks ago at my kid's school, and first thing, some 6 or 7 year old kid comes, hey, I want to make a game. I said, excellent, but we got to start somewhere else first. Let's start with some basics, and then they're still really keen. So here's how we can kind of create a very, very simple game. This is a cat and mouse game. The mouse moves around randomly on the screen, and then you use the arrow keys to try to catch the mouse. I realized that if you just leave the cat there, the mouse will eventually run into it. Maybe I should have switched it around so as a mouse you're trying to avoid the cat. But, and again, you can see this example. It's in the slideshow there and how to make it. Are there any questions? Yeah.
Is this the program you use with the Makey?
With the Makey, when I had you guys come up here to play Pac-Man, I actually just downloaded a Chrome app for Pac-Man. So this will actually work on anything. So I can actually, if I'm holding the ground wire now and holding the whatever this is, I guess this is the up, and I start this program again, I can actually control the cat. So it just takes place of the keys, the physical keys on the keyboard. And some teachers do some interesting things with this. They do like a make your own Dance Revolution style game with the arrows on the floor and step on them and start to see where you go. Any other questions? Yes?
This might be something wrong, but is there a way to clear that size without programming clear?
No.
Oh.
I was trying to think if there is. I mean, you can start over, I guess, right? But I don't know if that's exactly what you're after. Any other questions? Excellent. Well, thanks very much for coming. Make sure you take the time to, if you have a moment, just to fill in on the app, the session evaluation. I'd love to get some feedback, and it doesn't all have to be positive. I'm very open to constructive feedback, so please be honest. Thanks for coming, and enjoy the rest of the day.